Hello everyone, we are solving intersection point in Y-shaped linked list problem. So let's check the problem statement and input. So this is our input. We have given two linked lists and they might or they might not have some common part. So if they are intersecting at some point, that means they are having some common part, then we have to return the first node where they are intersecting. So if we check this example, the linked list with head node 3 is intersecting with linked list with head node 10 at the node 15. So in that case our result output is 15. So here I will just write 15 and 30 as they are the part of entire linked list, and I will just remove this common part. Okay, so and I will shift it to the right side till common parts are overlapping. So here we can see that or let's make one observation. So number of common nodes. So if you observe this thing, the number of common maximum number of common nodes are never gonna be greater than the minimum number of nodes in the uh, nodes with uh, linked list with lesser nodes. So what I'm trying to say, I will explain it in this example. So here the linked list 1 has 5 nodes while linked list 2 has 3 nodes, but so in that case maximum possibility of having common nodes is gonna be 3, as the entire the size of entire linked list is 3 in this case. So we cannot exceed common nodes more than our linked list with less number of nodes. So let's so here we can see number of nodes in shorter linked list. So this is the case. Maximum number of common nodes between two linked lists are never gonna succeed, or the never gonna be larger than number of nodes in shorter linked list. So we are going to use this property to solve this example problem. So for that we need to find length of both the linked lists. So I will just make one function for finding it. Let's just start from here. So let's say node temp A, which is pointing to head A, and node temp B, which is pointing to head B. So let's make two functions. Len A is equal to, and let's make function. So let's call it list len, which is gonna take node as argument and is gonna return integer containing size of that entire linked list. So what you can do, let's declare one variable as size, and we are gonna run our loop till our node is not null, as we are going to travel to the next node each time, and at the same time we are going to increase our size variable. So let's increase size variable, and node is gonna be at the next node. Okay, in the end we can just return size. So here we can store sizes of both the linked lists. So let's have temp A. Here you can notice I am not using this given head to finding our list length, as here we are modifying list and traversing node to the next node. So if we use head A here, in the end we will get our head A equal to null. So we will lose our pointer to our head of our linked list. So for that we are using temporary variables or reference variables. So length is gonna be list len of temp. Okay, so we can make one check. So if len A is less than len B, I am considering len A as greater, than len b. So if it is lesser than len b, we will just call this intersect point function again with nodes swapped. So in that case we will just return intersect point head b. I am doing this for avoiding further confusion and extra test cases. So after that we can find the difference between those two linked lists. So when diff is len a minus len b. So here we can see, for finding the common part we should traverse both the linked list with the same size. So for finding common point in those two linked list, we have 3 as a size of our shorter linked list. So we will just remove or ignore first two nodes, and we will traverse from the node 9 on node 9 to find our common part. So we can just remove it here, and you can clearly see from this example. So if we start from traversing from node 9 and node 10, and as they are not common, so we will move to next nodes. So we can just remove it, and now if we can see, if you can see, we got our common nodes. So like this we are gonna traverse from the both the linked list by creating same size or just ignoring nodes which are extra in the larger linked list. So what you can do is, so we have our difference between those two linked lists. So while our difference is greater than 0, this means difference minus means per step it will decrease our difference by 1. So what we are going to do, head a is equal to head a dot next. So in this case we have difference 2, so we are gonna traverse our linked list 2 points ahead. So while our difference minus is greater than 0, that means we are gonna travel this linked list 2 times. So our new head is gonna be at 9. So after that we are gonna have same size of both the linked lists. So for that we are doing this step. So now we will point to our heads or the new head and node b to our other linked list, as it is gonna be unchanged as it is shorter. So let's make one while loop. While our node a is not equal to null and node b is also not equal to null, what we are going to do, we are going to check if node a is equal to node b, node b. So in that case we are just gonna return node a dot data as we get our intersection point, uh, which is first intersection point. So we are gonna just return from it from there. uh, if we are if we don't get we are if we don't get those nodes equal, so we are gonna traverse the remaining linked list. So in that case node is gonna be node a dot next, and node b is gonna be node b dot next. And if we traverse our entire linked list and didn't find any common point, so in that case we are just gonna return -1 as they have told us to do. So let's try to run this code. Okay, it's running. Let's try to submit it. Okay, and we are passing all the test cases. So what we have done is, we have checked the lengths of both the linked list, and we have skipped number of nodes which are extra in our larger linked list, as they are not gonna be common in any case. So for that we have skipped those nodes, and after that we just check each node as if they are equal. If they are equal, we are just returning our integer value from there, and if they are not, we are just traversing till our linked lists are not null. So this is the solution. So thank you.